We're going to continue reviewing reactions of alcohol. And again, I am starting with the same molecule and seeing a different set of conditions, several reactions, and see what is the final product. This time, I am using my first reaction is going to be tosyl chloride, and this is done in pyridine. The second reaction is ethoxide, and third reaction is ozone, and this is with dimethyl sulfide. So let's review all of these reactions. So now, what is tosyl chloride? This, if we notice the second reaction, there is a ethoxide, so strong base, and also strong nucleophile. So this reagent we use to transform OH into a beta leaving group when we're going to carry out a reaction under basic conditions. In previous video, we have studied that we can transform OH into a good leaving group by protonating it. So the leaving group in that case will be water. But if we're going to be working under basic conditions, then we cannot protonate. So we use tosyl chloride to make this a better leaving group. So the product then of the first reaction is going to be the following, OTS. But what I want you to notice here is that the stereochemistry at this center hasn't changed. And it hasn't changed because the reaction had not occurred at the chiral center. It happened at the oxygen. And so tosyl chloride, let's say, what is that? Is this. Yeah, let's do that. But what's going on here is the attack of the oxygen over that, over my reagent here. I'm gonna be a long arrow. After several steps, you get the tosylate, but the point is, you're not using that chiral center. This is not being used. You're not touching it in that reaction. All of the change has happened at the oxygen. So there is retention of configuration at step 1. Let's go over to the second step now. Strong base, strong nucleophile. But this is a secondary alcohol, so the preferred reaction is going to be the ether. And this is what we're going to be drawing. So what's going on is that this is a small base also. So the preferred product is going to be decisive, which is the more substitute alkene. So we are going to get the following. And notice here to make the, we are doing this product. So that is decisive. Oh, decisive is with a Z and not an S. So the more substitute alkene. Now the third reaction now is ozone and dimethyl sulfide. So that is an ozonolysis reaction, and that's used to break carbon-carbon bonds. And from that, you're gonna make on each end an aldehyde or a ketone. So I'm going to draw the product of that reaction, say in a closed form, and then we're gonna be extending it because it's easier to see. So this is ozonolysis. And let's do the product. Here I am going to breaking that. I'm going to insert the oxygen here. And we're going to keep drawing that. And we're going to put an oxygen on the other end. So notice this is that inserting oxygen on each side. This side is an aldehyde. This side is a ketone. And now we're going to be redrawing this. So we're going to make another drawing of the same molecule. This ketone has an ethyl group on that side, and here I count 1, 2, and 3 carbons, and that's a fourth. So 1, 2, 3, and 4. and that is an aldehyde. So again, 1, 2, 3, 4, 1, 2, 3, and 4. That is a product, only this is at an extended conformation. So that's the final product after all these sequence of reactions.